Yeah, so I'm Simon. I'm a developer on gov.uk. Sorry, that's really loud. And I'm going to talk to you about how to steal software from your government, but then just like borrow it from GitHub. So a while ago, DHH, the founder, inventor of Rails, this is going to be a little bit stretched. He talked about the value of view source, and it stuck with me because I learned to program and HTML, CSS from doing view source in the browser. So I was talking at Brighton Ruby about this. What if this worked for all backend code? Well, some context. I work on a project called gov.uk. We have something like 15 million visitors each week. It's the main site for government, so we have all of the organizations, all the departments are on here and publishing news and statistics and things like travel advice. Also, a lot of guidance and policy documents about what to do in certain situations. If you want, for example, to keep a micro pig, this is real guidance. And it includes the instruction not to walk the micro pig past a fast food restaurant. And we're not entirely sure if this is like hygiene reasons or like not causing the animal distress. So all of the code for that page and all of the other pages is available on GitHub. We have a GitHub organization called AlphaGov, and it contains something like 1,600 repositories, like 300 or 400 are for gov.uk alone. So it includes a bunch of archived repositories. So the reason why we open up all our code is that we believe that to make things open is to make things better. So a bunch of reasons why opening up code is good and working in the open is good. So it makes things more secure. It's basically because like taxpayers have paid for this code to be written. So why not? Why can't they? Why shouldn't they be able to see it? And one good reason is because people can learn from your code. So what I wanted to do in this presentation is quickly go through a couple of examples, by no means all of the stuff, of code that might be interesting in a future project or something just to look at if you're learning Rails or learning Ruby. I'll put the slides up here so you don't have to write down all the repo names. So I want to give you three examples of free real-world apps that we have that you can look at. There are 70 Rails apps that you could read through. But these three are quite interesting. Three cool patterns, things to help with big projects, and some team tools. So the first real big app is called Whitehall. Sorry, there. And this is one of the oldest applications that we have, and we have the original committer even here in the room. So it's actually eight years old. It started off as a Rails-free application, and it's been upgraded ever since, and it's now just on Rails 5, and it's still chugging along. It's been decomposed into more and more microservices, but it has lots of interesting things like the main model, and it runs in two separate modes, so an admin mode and a normal front-end mode, which is I think the only place where we do that. Then there's a new thing that we have, and it's a data warehouse. It's called Content Data API. And what's special about the data warehouse is it takes information about our publishing. Also, every page that is published, we keep track of it. And then we download Google Analytics data, and you can use it to analyze like traffic patterns. And it uses a star schema for the database. And that's a thing that's been around since the 60s. And it's basically a very denormalized database. So if you're ever running into, like, your boss tells you I want a data warehouse, you could look at this as an example. And then an interesting new thing, new application that so the latest thing that we've started, it's called Content Publisher. And in it, we do architecture decision records, also called ADRs, and those document the decisions that we're making about the application. And we're doing that in a bunch of the applications. But this describes how we move like logic out of the controller, which is a problem that you'll see in every app. Controllers becoming too big. And what do you do? Do you make service objects, or do you use a gem to extract logic, or do you put it all into models? So there's a lot of cool stuff to see there. So then on to 3 cool patterns. Readable feature specs. So a couple of years ago, FutureLearn wrote a blog post about feature specs. So feature specs are the highest level tests that you can have in an application, and it describes how what a user does. So in the example of FutureLearn, like given there's a course, I'm logged in. So that kind of stuff where you're actually like impersonating a user and then interacting with the application. So we've used that pattern from FutureLearn and ran with it. And if you want to see like how it's used in practice, we think it works quite well for us. There are about a dozen or so of these tests, maybe more, in this repository, in Content Publisher, which is the new app. Spam honeypot. So, is anybody here working on like large-scale prescription drug spam? Like to? Okay, so good. Keep this secret, please. We have a contact form on gov.uk. It is just it's a form, and you fill in your name and your email address. And it turns out we get a lot of spam through this. So you can do a couple of things. You can build a machine learning pipeline and train a neural net against what are spam messages, which will probably like yield false positives and annoy users, or you can annoy the users directly and use CAPTCHA. But a third way, which is actually quite effective, is to add a little snippet, a little input field into the form with a weird name. This is called giraffe. And robots will actually go in and fill in every form. And what we do is we hide this form with CSS. So normal users would never fill in this particular input field. Only robots do. So if we, when the thing is submitted, we just check if a robot has filled anything in, and then we discard the message. So this is surprisingly effective for a lot of spam messages. It covered like 95% or so of our stuff. This is all in the feedback application. Archiving a lot of stuff. So this is our product manager, Martin, deploying our new email system in April of last year. He's pressing the Capistrano party, which means that from then on, we were sending about 1 million emails to people who subscribe to things like travel advice alerts or news from a certain department. So you can imagine that the application that actually does the sending is just a Rails application, and it has an email model and an emails table. So it grows and grows and grows. So we had to do something about that, and what the team came up with is to archive all of the records, like something like every day. We loop through all of the older emails, and we zip them up and send them put them in an S3 bucket on AWS. And what's really awesome is that if you format the directory structure of your S3 bucket in a certain way, so you use a year and a month and a date, then suddenly you can use an AWS service called Athena to basically query the S3 bucket as if it was a normal database. So it's super useful for logs and for just archiving a lot of stuff, because the buckets can grow infinitely. And it's useful for long-term stuff. So that's all in Email Alert API, if you want to take a look at that. As I said, we have like 300 or 400 repos. It's a lot to configure. What we want, like all of our repos, we want that we only allow merge commits because we care about the commit message. Want to protect the master branch using GitHub branch protection, so that you can't push to master, force push to master, and your CI has to pass. Test has to pass on CI, and we want to configure some webhooks. So we have a little tool for that. It's called CoffeeK SaaS config, and it basically loops through all of the repositories tagged with CoffeeK, our team, and sets the correct permissions using the GitHub API. You can find that here. So sharing front-end code. We have, of those 70 applications that we have, about 16 are front-end applications, so they're part of CoffeeK if you visit it. So we have buttons and things like input fields and checkboxes that we want to reuse across applications. So if you have multiple front-end applications, we wanted a component to build a component system, and our component system works with a convention of like naming. This is the backlink component. So you name your part. You create a partial, and you name your assets as such, and then you create a YAML file which describes your components. YAML file looks a bit like this. There's a name. You have a name, a description, and some examples. So this allows you then to spin up a component guide, which is a thing that was built, which takes all of those partials and puts the partials in, like renders the actual partial, so you can see what your component looks like. This is a really cool system, and we use it to basically ship all of our front-end code. You can look at here. Visual regression testing. To make sure that all of those like CSS changes go well, we use visual regression testing. So I'm not sure how many people are familiar with Heroku review apps. What it means is that every time you make a pull request, it creates a new application on Heroku using that code, so your teammates can click through it and test manually. And what the team came up with was a tool to make shots of the review app and then compare it to the screenshots of production. So you can actually see what kind of visual changes you're shipping. We use a tool from the BBC, it's called Rave, to actually do that part. But the output is a list of things, of screenshots and the differences between the screenshots, ordered by how different they are. So you can also see like where things might have gone wrong, or well, look at that CoffeeK visual regression testing. So finally, some team tools. The seal of approval might be like a classic already at LRUG. I think it's been talked about a number of times. You configure it with your team's usernames, and every morning at 9:30 it will tell you that there are pull requests to review. If you don't review the pull requests, it will become an angry seal, and it will yell at you and tell it it's sad because you need to review pull requests. It was made by a developer on Gov.uk, Tatiana, and you can find her on her GitHub. Another thing that was built in 20% time at Gov.uk is the GitHub Trello poster. It's a tool that you can use. You paste the URL of a Trello ticket into a pull request. It will automatically create a checklist for that thing with linking out to GitHub. And then when you close the pull request, when you merge the thing, it automatically checks off the checklist. So it's a really easy way of seeing which pull requests are still open on Trello cards, because Trello shows that on the cards. That's GitHub Trello poster on Emma's GitHub. Final thing, browser extension. This is a simple URL on gov.uk. That's the staging URL. We also have an integration environment. We also have a development environment. This is the production environment, but then uses an API to get the content. This is another API that we have. And we also use like external services. So this is a link to the same URL, but then you can see the National Archives version of it. So you can see like the history of the page. So to remember all of this, we created a little browser extension which allows you to switch between production, staging, integration really quickly. Like it stays on the same URL, just changes the domain. And then it can also change into like to the APIs or National Archives or any of the other. Like we have got a bunch of stuff we can use. Isn't Ruby, of course. It's JavaScript, and it's on GovUK browser extension. It works in Firefox and in Chrome. So those are some of the examples. If you want more, there is incredible amount of stuff that you can view from government and government-related organizations. I think GitHub's like the UK's. This is the GitHub for government page, and the UK has the most GitHub organizations, I think. So all of the departments and lots more organizations have code in the open. If you want to code in the open yourself at Gov.uk, we are hiring. We are also hiring specifically now for Ruby developers. So if that's something you'd be interested in, then come talk to me afterwards. Otherwise, slides and links are over there. That's it. Thank you. Questions?
You have time for questions?
Yeah, sure.
I have three questions. One is, how is your code licensed?
MIT.
Okay, cool.
Oh, sorry, the question was, how is the code licensed?
Second question is, have you ever had pull requests from external people?
Right. So the question is, did we ever have pull requests from external, outside of GDS? Not much. I would say like once every 6 months. It's really not like it's surprising, but I'm not sure why. I think it's hard to get really into to understand it from the outside. Yeah.
Were any of those useful?
Were any of the pull requests useful? Yes, I think a couple of weeks ago somebody fixed something in our documentation that was really weird. So that was good. Yeah. Yeah. Thank you. Yeah. So yeah, we don't have a microphone. Yeah.
Thank you for the presentation, actually. One. Secondly, when you started with governments, in terms of the .gov portal, were government departments a little bit resistant to the idea in the beginning? Or were they like quite enthusiastic and they were thinking, guys, we need to come into the real world now?
Coding in the open specifically, or? So the question was whether government departments were enthusiastic in the beginning of GovJK, and I don't think they were, but they've come around. And especially coding in the open, there's been a lot of work, and I think across government, people now really appreciate that that it's good to work in the open, and that it really makes the code better, and it's a lot easier to collaborate also with other government departments. So. No more?
How's it going with microservices, and are they mostly Ruby, or are you using different languages now that you're splitting them up?
Yeah. So the question is about microservices. I think that's a whole talk on itself, how we approach microservices. But yeah, it's been a journey for the last couple of years. Yeah.
Are you satisfied, or is it difficult? I mean,
It's difficult. It's difficult. You bet. My personal opinion about microservices is that you trade certain problems for other problems. I think the problems that we have are now better than living in having a single monolith. But there's definitely a lot of stuff that we need to do, like the many GitHub repos and the organization and just general communication and sharing code between applications. That's just a lot harder in microservices. Good.
Is developing in the open ever an issue? Say you're developing guidance around a policy that's going to be controversial, which isn't public yet.
Yes. So the question is it ever controversial? Yes. So there are two reasons why we code like not in the open. It's security issues. So when we notice a security issue, we often close the repo or do the fix somewhere not in public. And the second thing is that in some cases policy might not be announced yet, and then we have to make the repositories private and then develop on that. But in practice, it hasn't happened that much that it's been a problem. No. Yeah.
Because you develop everything in public, do you have to release things like later? Because you don't want bad code being seen earlier.
Whether we deploy later or develop later because of public, I haven't noticed that. We generally develop in public, and the amount of scrutiny is a lot less than you would think. So there's not really. Maybe after this, that's the point of the presentation. Come on, look. But there's never been a case of somebody from the public coming in and heckling government because of don't use callbacks and something like that. Go. Sorry.
Does developing in the open lead to more discipline? So, what's your experience in terms of, for instance, commit messages?
Right.
I saw some fixed typos on one of the slides.
Yeah. Does it lead to more discipline? Coding in the open. I think it leads to. I think it does. I think it's a lot harder to actually just smash the keyboard and this is your commit message. Sometimes those things get merged accidentally. I think we have very few swear words compared to maybe private code, and I think for me it at least does. I know in the back of my head that this is code that people can look at. It makes me write better progress.